ready to take your Auth0 protected FastMCP server from development to production without losing security or state. You'll see exactly how to configure persistent token storage with encrypted Redis, ensuring OAuth tokens survive server restarts while keeping sensitive data locked down. We'll wire up the full production setup, from environment variables to Fernet encryption, so your authentication stays seamless and secure at scale. Import Auth. From FastMCP, import FastMCP. From FastMCP server auth providers Auth0 import Auth0 provider. From key value AO stores Redis import Redis store. From key value AO wrappers encryption import Fernet encryption wrapper. From cryptography Fernet import Fernet. Hash production setup with encrypted persistent token storage. Auth provider equals Auth0 provider. Config URL equals https:// well-known/OpenID configuration. Client ID equals tvtoab ngazawwh hiker 7bz1 lutamxln smsb. Client secret equals vp junk. Audience equals https:// base URL equals https:// your production domain com. Hash production token management. JWT signing key equals OS. Environ JWT signing key. Client storage equals Fernet encryption wrapper. Key value equals Redis store. Host equals OS. Environ Redis host. Port equals int OS. Environ Redis port. Fernet equals Fernet OS. Environ storage encryption key. MCP equals FastMCP. Name equals production Auth0 app. Auth equals Auth provider. This demonstrates the OAuth proxy pattern combined with secure credential storage for production authentication. The code bridges Auth0's dynamic OAuth configuration with FastMCP's authentication requirements, while adding encrypted persistence for tokens and client registrations. What makes this distinctive is how it handles both the authentication flow and secure storage of sensitive credentials in a distributed environment. The pattern works by delegating authentication to Auth0 while maintaining control over token management. The FastMCP server uses Auth0's OpenID Connect configuration to handle user authentication, then stores the resulting tokens in an encrypted Redis backend. This separation means your application code stays clean of authentication logic, while still benefiting from production-grade security features like token persistence across restarts and encryption at rest. This approach solves two critical production challenges: maintaining stateless authentication while surviving server restarts, and securing sensitive tokens in distributed systems. Without this pattern, you'd need to either sacrifice persistence, losing sessions on restart, or implement complex token storage yourself. The trade-off is added infrastructure complexity for Redis, but the security and reliability gains make it worthwhile for any production deployment. Let's break it down line by line. Import Auth. Imports Python's Auth module for environment variable access. This enables secure configuration by pulling sensitive values like API keys and encryption keys from environment variables, preventing hard-coded secrets in source control. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI-callable tool systems. It handles authentication, tool registration, and request routing between Python functions and AI models. From FastMCP server auth providers Auth0 import Auth0 provider. Imports Auth0 provider, the authentication handler for FastMCP that integrates with Auth0's identity platform. This handles OAuth2 flows, JWT validation, and token management while abstracting the Auth0 API complexity. Production-grade auth in 2 lines instead of building it from scratch.
From key value, AO stores, Redis import Redis store.
Imports Redis store, a persistent key-value storage backend. This handles token storage across server restarts, ensuring sessions remain valid between deployments.
From key value, AO, wrappers, Encryption import Fernet encryption wrapper.
This imports Fernet encryption wrapper, a transparent encryption layer that wraps key-value storage. It automatically encrypts all data before storage and decrypts on retrieval, ensuring sensitive tokens remain secure at rest while maintaining normal dictionary-style access patterns. The wrapper pattern here eliminates the need to manually handle encryption in application code.
From cryptography, Fernet import Fernet.
Imports Fernet from cryptography, the symmetric encryption standard for secure token storage. This provides the cryptographic primitives needed to encrypt and decrypt sensitive data before it's persisted to Redis, preventing exposure of raw tokens in storage.
Hash production setup with encrypted persistent token storage. Auth provider equals Auth0 provider.
This instantiates the Auth0 authentication provider with production-grade security. The provider handles OAuth flows, token validation, and user identity management while integrating with FastMCP's auth system. Encrypted persistent storage for tokens prevents session hijacking and ensures compliance with security best practices.
Config URL equals https://well-known/OpenID configuration.
This is Auth0's OpenID configuration endpoint. It provides all necessary OAuth2 metadata, token endpoints, supported flows, and public keys, eliminating hard-coded values. The server fetches this once at startup to auto-configure authentication.
Client ID equals tvtoab ngaz zawwh hiker 7bz1 lutamxln smsb.
The cliented is your application's unique identifier in Auth0's authentication system. It tells Auth0 which application is making the request, enabling proper token issuance and validation. This is a required OAuth2 parameter that must match your Auth0 application configuration.
Client secret equals vp-junk.
This is the OAuth2 client secret for Auth0 authentication. It verifies your application's identity when exchanging authorization codes for tokens, preventing unauthorized access to the Auth0 API. Never commit this to version control. Use environment variables or secret management systems in production.
Audience equals https://
The audience parameter specifies the resource server identifier for Auth0 token validation. It ensures tokens are only accepted when intended for this specific API, preventing token misuse across different services. This is a standard OAuth2 security requirement for validating token scope.
Base URL equals https:// your production domain, com.
Sets the canonical base URL for all Auth0 callback and redirect operations. This ensures consistent domain handling across authentication flows, preventing mismatched redirect errors in production environments.
Hash production token management. JWT signing key equals OS. Environ JWT signing key.
This sets the JWT signing key from environment variables, ensuring secure token generation and validation. Production systems must never hardcode cryptographic keys, so we pull this from the environment at runtime. This follows the 12-factor app principle of storing credentials in the environment.
Client storage equals Fernet encryption wrapper.
This wraps Redis storage with Fernet encryption, implementing the decorator pattern for transparent data security. Every token stored in Redis gets automatically encrypted at write and decrypted at read, preventing exposure of sensitive credentials in persistent storage. The pattern keeps encryption logic separate from storage logic while enforcing security by default.
Key value equals Redis store.
This instantiates a Redis store, the persistent key value storage backend. It handles token storage across server restarts, replacing volatile in-memory solutions. The Redis connection details come from environment variables for production security.
Host equals OS, environ Redis host.
This pulls the Redis server address from environment variables, enabling secure configuration management. Externalizing host values prevents hard-coding sensitive infrastructure details and allows environment-specific deployments without code changes.
Port equals int OS, environ Redis port.
Environment variables are always strings, but Redis requires an integer port. The int cast converts the environment variable to the correct type, preventing connection errors from type mismatches. This is a standard pattern when reading numeric values from environment variables. This closing parenthesis terminates the Fernet encryption wrapper instantiation, finalizing the production token storage configuration. It completes the nested setup where encrypted Redis storage handles sensitive JWT tokens, ensuring secure persistence between sessions. The pattern combines encryption with key value storage for compliance-ready credential management.
Fernet equals Fernet, OS, environ storage encryption key.
This initializes Fernet symmetric encryption using a key from environment variables. It ensures all stored tokens are encrypted at rest, preventing exposure if the Redis store is compromised. The key must match what was used for encryption to successfully decrypt later. This closing parenthesis terminates the Auth0 provider configuration block, finalizing the production-ready authentication setup with encrypted token storage and all required OAuth parameters. It enables the subsequent FastMCP instantiation with fully configured auth, ensuring secure AI tool execution. The pattern shows complete dependency injection before core system initialization. This closing parenthesis finalizes the Auth0 provider configuration. It completes the production-ready authentication setup with encrypted token storage, making the provider ready for use with FastMCP.
MCP equals FastMCP. Name equals production Auth0 app. Auth equals auth provider.
This instantiates the FastMCP server with production-grade Auth0 authentication. The auth provider we configured earlier handles all token validation, encryption, and secure storage, while the name parameter identifies this instance in logs and metrics. This is the entry point where your AI callable tools get connected to the authentication system and exposed to models. Production-grade OAuth security. The combination of JWT signing keys and encrypted Redis storage creates a resilient authentication layer that survives server restarts while protecting tokens at rest. Plaintext storage of OAuth tokens creates catastrophic security vulnerabilities that encryption wrappers prevent. Always use environment variables for secrets and persistent storage backends for distributed systems.
The key that never leaves the vault unlocks every door.